Hey, welcome today. I want to give a quick overview of what we're going to go through. We've had a long partnership with IBM and H2O. ConvergeOne really prides ourselves in having strategic partnerships, over 300, and we're a very engineering-oriented organization. Over half of our employees are engineers carrying numerous certifications. And we do this and serve kind of a really blue-chip, diversified customer base, as you can see on this chart. More importantly, we're in 77 locations, and we have worldwide operations. As part of ConvergeOne's effort to kind of bring the latest technology and solutions, we've partnered with IBM. We've been an IBM Platinum partner for over 20 years now. And when we have these type of partnerships, it allows us to kind of bring great solutions at a great point. When we have these solutions, it raises our customer satisfaction ratings. As you can see on the NPS score, overall we have a 70 on a scale of -100 to a +100. Leading industry examples is 33. Apple, for example, has one of 47. So we do this to really help our customers perform and see their business value come to fruition through the IT area. One of the partnerships I've been most involved with is IBM and H2O. I want to turn over to Rafael Coss now from H2O to walk through automated machine learning and how that can really increase your AI and performance with the help of IBM.
Select our response column, which in this case
Thanks, Glenn. My name is Rafael Coss, and I want to talk to you folks a little bit about automatic machine learning. But before we go there, I want to talk to you a little bit about H2O as a company. So we're a startup. We've been around for about almost 8 years. We have 2 product lines, an open source product that many folks have been using around Python and R. It's a scalable machine learning engine. And then we have our automatic machine learning platform, Driverless AI. We're about 125 people at the moment with experts in data science, Kaggle Grandmasters, distributed computing, and we have offices all around the world. We have been, H2O is being used by many of the Fortune 500, so 8 out of the top 10 banks, 7 out of the 10 top insurances. We have a very large community of users using the open source every day. There's something in around 200,000 data scientists using H2O. We have an active community via meetups. Actually, we have H2O World in New York that's coming up soon. I think it's October 20th. And that's our annual user conference. And then we are actually being used by many large enterprises around the world, whether it's Citibank or Capital One or Wells Fargo, or across various different industries, whether it's retail and Walgreens, with Macy's, insurance with Progressive. So we're used across many different industries. I want to mention a little bit who our team is made up of. Right, part of it is Kagglers, and in particular we have many Kaggle Grandmasters. So Kaggle is a community data science competition. I think there's something like 300,000 active Kagglers. So the top 130 Kagglers in the world are called Kaggle Grandmasters, and at the moment we have 13 Kaggle Grandmasters. That's 10% of the world's expert data scientists in Kaggle work for H2O Data AI. Right, and along with those, we have many other expert data scientists, and what we're doing is we're helping to automate the machine learning and these best practices in a tool called Driverless AI. So we're recognized as a leader in AI and the machine learning, whether that's in Gartner or Forrester, right, or whether it's directly by customer feedback. So here you can see a Gartner Peer Insights review, where we're ranked very highly by what the customers think about using our product. As I mentioned, we have 2 main product lines at H2O. So we have our open source with H2O, sometimes referred to as H2O3 or H2O Core, and Sparkling Water. Right. So H2O is a distributed machine learning engine that can work in the Spark, Hadoop, or Kubernetes environment. Sparkling Water is basically a library that makes it easier to work with H2O in a Spark environment, which means that if you have a smart context and you want to create a smart data frame, from that you want to create a H2O frame, this allows you to easily go from your smart frame to an H frame, and once you come to an H2O frame, you're just using H2O. So this is sort of integration, so you can do data prep with Spark at scale, and then build machine learning at scale with H2O or H2O and sparkling water. Our other offering is a commercial offering, which will be the focus of today's talk, is around Driverless AI, right? And that's really focused on enterprise automatic machine learning, right? And so we try to simplify, automate, and make enterprise-ready the machine learning process. So let me dive a little deeper into what we're doing with machine learning. So as we, clearly machine learning and AI is definitely picking up steam within the industry, whether you're looking at, Forrester reports, increase in spend, job postings, right? Or like looking at priorities and CIOs, AI is becoming a reality. And, folks are moving from sort of ideas to production very sort of quickly now. For the folks who are not as familiar with machine learning, this is my quick intro. We're really focused on supervised learning, and what supervised learning tries to do is learn by example. So here's an example where we have a training data set that has some events where people are defaulting payments. So the default sometimes, that one column sometimes also referred to as a feature, where we have the example is often referred to as a label, right, where we're trying to find and identify the pattern. And what happens is, given new events, can we identify, given particular characteristics, whether someone will default or not on the payment, right? And that's what we want to do is figure out that pattern, and that pattern sort of encapsulated in something that we call a model, right? So once we have a model, we will be able to guess or determine with a particular probability whether someone will or will not sort of default on a loan, right? And so this is sort of an introduction to supervised learning. As we look at supervised learning, it really has two major categories. One is a classification, where you want to group sort of events. So the last example was around someone defaulting or not defaulting on a loan. That would be a classification supervised learning technique. The other one is regression. So if you're looking at forecasting sales into the future, that it will probably be something that's sort of continuous, and that's sort of regression. And Driverless AI supports both of these techniques. As we look at supervised learning, we're very much focused on tabular data, right? So at the moment, we are focused on tabular data and supervised learning. On our roadmap in the future is, more around unsupervised learning and things like images. But at the moment, it's tabular. We also have particular recipes around time series. So if you have a time series machine learning problem, we can definitely help you out with that. We also support NLP, right? So as we look at NLP, that use case is really focused around categorizing documents, right? Whether you're categorizing a document that's a tweet, it's positive or negative, or you're categorizing a document where you have a call center, right? And there's a call, and that call might be either a question or a sales request or a configuration change, being able to categorize various documents. So how are people using machine learning? So clearly machine learning and Driverless AI is being used across many industries, insurance, financial, manufacturing, retail, healthcare, and many more. Here's a sort of a quick look into the various sort of industries and kind of some of the benefits that people are getting, right? So there's folks like PayPal who have been using Driverless AI and actually been doing machine learning for a very long time, and applying Driverless AI have seen an improvement in accuracy, right? So many customers are seeing things like improvement in accuracy, improvement in productivity, faster time to deployment, right? And that's what folks are trying to get at with automatic machine learning. Right. The other thing is that people are seeing an improvement in performance using sort of our low latency scoring. I think you can see Stein and Decker is saving a month time in deploying a new model into production. So here's just a high level of some of the different industries and the types of use cases that people are looking at. So within financial, looking at things like know your customer, credit card payment of business, retail banking, healthcare, looking at sort of early detection of cancer, finding the right doctor, telecom, like, a preventative maintenance, looking at churn, marketing, trying to look at and sales and looking at your pipeline forecasting. So this is just like a short sample of the various different use cases. On our website, you can find a long list and much more detailed on each of these use cases. I want to talk about a couple of use cases in a little bit more detail. First and foremost, I want to talk about a use case with Vision Banco. So this is actually a joint win with IBM, where IBM provided the hardware, the IBM Power system AC922, where it runs workloads on-prem for this customer, leveraging CPUs, the power chip, and GPUs, right? And so customers have really have seen a lot of benefit in the advanced feature engineering that automatically gets generated. They've seen an improvement in the accuracy for their model and doing it in less time, right? So one model in particular, they saw a doubling of, it was a model to identify people propensity to buy. And so they doubled their propensity to buy, leveraging the technology between H2O AI and IBM. Here's a blog that the lead data scientist wrote on what they thought about driverless AI. I like to sum it up by focusing on two key aspects. One of them is he saw this as a cattle grandmaster in a box, right? Having these expertise around exploratory data analysis, feature engineering, hyperparameter tuning, machine learning explanation, all automatically done for one. And so at the end, they saved cost and speed in deploying additional use cases. So this is all about, people can kind of do it all by hand, but that just takes a lot more time. And it's not just about building a model, but building several models and getting, how much time does it get you to get to an actual accurate, how much time does it take you to build an accurate model? The other sort of use case, also sort of with IBM, is with PayPal, right? And so PayPal is a very advanced and mature machine learning organization, and they've been doing machine learning for a very long time. In this case, they had a model they spent 10 years developing and doing feature engineering, right? And using driverless AI, they were able to speed up their development, automating many of the complexities, but also saw an increase in the accuracy of the model that was developed. So we also have sort of use cases in healthcare and trying to match the patient with the right specialist. And this is Armada Health. This is using a lot of NLP, natural language processing, and supervised learning to make these matches. The other sort of use cases around sort of marketing optimization. So there's a company called G5, and they have a whole collection of real estate agents. So they're also using NLP technology from the call centers to identify sort of intent of people as they call in and help them find the next best offer and matching them. So they've seen significant benefits, not just in time and performance, but financially in the bottom line, right? Stanley Decker has a sort of a use case around supply chain optimization and optimizing their manufacturing and sales process, right? So they saw a saving of 25% by a data scientist, which ended up saving over a month, right? And really seeing good productivity and actually improvements also. So as we talk about automatic machine learning, we really see this going through multiple generations, right? So, part of the thing is, data scientists have a very challenging job, right? They need to understand and work with the business and determine the problem and how that can be automated and facilitated by using AI and machine learning. They have to go through a process of data processing where they clean and transform the data and get it ready to do machine learning, and then actually work on the process of building all these models. So these data scientists have to have all these different skills. Part of it's the computational skills, clearly have math and statistics skills, right? And have business insights and work with the business domain aspect to be able to kind of build these things, right? And that's where this can be very challenging for many enterprises to find data scientists, especially data scientists with a particular skill level. So sometimes people talk about data scientists as being unicorns because they're so rare, it's hard to find, right? And that's where we're looking at things like automation to be able to help junior data scientists work and be productive like more senior data scientists. And for senior data scientists to be able to focus on bringing on more use cases more quickly, right? So how do you sort of improve the productivity of these data scientists, right? So this is where like we really want to bring in sort of AutoML, right? So yes, your data scientists can manually code and select algorithms, manually do feature engineering, manually generate documentation, manually do exploratory data analysis. But why do that when you have potentially a better tool to help you automate that? So as we look at automatic machine learning, this is really the process to select the right algorithm, do the feature generation, the hyperparameter tuning, do this in an iterative fashion, write up all the documentations, look and build additional models to kind of explain all this. And this is the process that we're trying to automate. And we really see this happening in people doing this in sort of multiple generations. The first generation is kind of like really focused on things like hyperparameter tuning, right? And maybe some folks are trying to do this at sort of a larger scale. So as we look at sort of the first generation of automatic machine learning, it's really focused around this algorithm selection, parameter tuning, and maybe some model ensemble, right? And there's many folks who do this in the industry. We actually even do it in our open source. So we have a tool called H2O ML that's really focused on these initial ones.
So we're going to
we have a blog that kind of focuses on what are some of the different flavors of AutoML and what you should be actually looking and considering, right? But as we look at the challenges in enterprises, we really see enterprises having three large challenges. One is around talent, being able to hire enough data scientists to deploy these use cases. And then the second one is really around productivity, like how much time does it take a data scientist to kind of go through this process? And how much time are they waiting in just computation, right? After you've gone through the process, you're just waiting for these models to compute, and this can be a compute-intensive environment. And lastly, as we were looking at moving decisions from people to algorithms, can we trust this, right? And in some industries that are regulated, this is, there's a strict requirement of how you define and explain models before you can kind of go to production, which can potentially slow down, moving actual models into production. So as we look at the second generation of automatic machine learning, that's really focused around more advanced techniques like feature engineering, where you do encoding, advanced encoding, and generating new features automatically, and also trying to make the deployment much simpler, right? How do you streamline the pipeline generation? Can you explain models? Can you generate auto documentation? And can you fit into a model ops environment, right? And this is where driverless AI is really headed, and it gives you the ability to get an expert data scientist using the best techniques from Calvin Grandmasters and industry-specific expert data scientists. It can reduce your effort from months to potentially hours, leveraging the automation in the tool and the acceleration by hardware potentially provided by IBM. And lastly, we want to facilitate the process of building trust, providing explanations, auto documentation, and auto visualization for these various models. And that's where we're looking to our product, Driverless AI, right? So Driverless AI is uses AI to do AI and streamline this process, right? So it delivers insights and interpretability. It provides an easy way to go through this process, leverage its understanding, look at the visualizations, and make a decision ready to deploy these models. So we start looking at this under the hood. This provides simple, fast, accurate, interpretable, and enterprise-ready machine learning, right? And some of that's being done, the automatic exploratory data analysis in the auto visualizations. There's a whole optimization process where we use a genetic algorithm to sort of optimize the models, the hyperparameters, the feature engineering to kind of produce the best model in the leaderboard, providing explanations out of the box, and then kind of having a whole collection of tool suite to be able to quickly deploy these models. So as we look at people in an AI architecture, right, people want to develop a solution. So there's this whole sort of architecture that needs to kind of happen to be able to deploy that solution, right? And driverless AI is really focused on the machine learning aspects, right? So it doesn't do data prep, and can work in a lot of different infrastructure. And then also, once you kind of develop the model, you can deploy that model, whether it's in real time or in batching, right? And those at that real time, once it's deployed in real time or in batching, those AI applications can then leverage that to do inferencing or scoring for your application. So as we look at our partnership with IBM, we have an environment where we can deploy these models for development and production on-prem, hybrid, and cloud with the IBM environment. We also have a sort of partnership with IBM sort of global services and additional system integrators to kind of help sort of deploy this environment. Clearly, we have lots of other different partners. Some of them work for various different connectors, different infrastructure, data prep, and consultants. So now I want to talk, actually want to pass it over to my colleague Robert, so he can talk a little bit more about the IBM and H2O sort of partnership.
Yeah, thanks a lot, Rafael. This is Bob Chesebrough. I'm getting a bit of an echo, but I'll go ahead and stick an earplug out. So I just did want to say that IBM provides really a key strength here in the three dimensions that Rafael mentioned about talent, time, and trust. What I'm going to camp on is the time piece. But so as we move forward, really what we look at, what we bring to the table underneath the hood of H2O is that foundation, is that platform. And for big data scaling, we have 2.5 roughly times more addressable memory on system, if you're looking at an on-prem system, that you can leverage. So that's huge. When you're talking about machine learning models and being able to address your data in RAM is key. Another one is the high-speed data transfers. So on average, on an order, if you're looking at feature engineering and just even this could just be down from memory to CPU even, you'd be looking at something like on the order of 1.5 times speed transfer for doing that task. And time is a key element in data science. I'm a data scientist. A lot of my time is spent waiting for models to return. So anytime that you can really soup up the engine, it really improves your productivity in not a linear way, in a non-linear way that it speeds you up, probably quadratic. The other thing is it's faster on the GPUs. So any time that you're dealing with machine learning workloads, if you can accelerate them on GPU, you got to do it because you can reap a 30x benefit just on that acceleration by itself. And our system provides that. And so I'm not going to go into this too much, but this slide really depicts some other offerings that we have around vision products. And with vision products, you can actually turn those insights in videos and images into data, metadata, that now H2O Driverless could manipulate and draw insights from. So this is kind of an overall view of sort of the process or the pipeline, if you will, for a data science project. Now, ignore sort of the details inside the box on the left. Let's just say that that's an x86 system out there. That would work just fine. What you're going to do is you're going to take your data, wherever it is, wherever your system of record is on the left, you're going to take that data. You need to do an ETL, extract, transform, load on that data. You would bring that over to a training server, like in this case, we'd be talking about an AC922 that's really souped up and has H2O Driverless built on top. And so some of the things that Rafael mentioned, you use H2O Driverless to really take advantage of that talent and that trust aspect to create a really good model. You're leveraging IBM Power 9 to take advantage of that time piece. And what happens is you create a model. a machine learning inference engine. Think of it. And so what H2O allows you to do is to export that model, let's say as a Java Mojo. There's other modalities that can export it as well. So let's say you bring it over as a Java Mojo. So you could actually plug that into your server, your system of record, wherever that data is, and then you could use that model there. And so that's kind of the overall flow. The reason that I highlighted these other pieces for IBM, for I, and for AIX is because they would already have their data on Power, and so they get an extra benefit in that extract transform load would be even faster. And so that's kind of a relative advantage there. But, I just want to give you a sense, too, of kind of the growth and kind of where we're going with this and what's available now. So H2O Driverless AI is available sort of out of the box already if you're already engaging or you're migrating to IBM Cloud Private, then H2O is there. And so, yeah, they have the Helm charts, they have all the things that you need to do, provided we're just saying there's some details there, but really what you do is in 3 to 5 minutes you can launch an instance of H2O on IBM Cloud Private. So you've got a sandbox. You could go right to town. So some of the benefits of Power 9 on cloud, is that robust containers. So a lot of you are familiar with sort of the Kubernetes and the Docker sort of methodology. Well, we provide that container catalog and that choice of your infrastructure as a service platform capability. And you can run both the Linux and the AI workloads. Alluding to that previous foil, if you are on an AIX system, you can actually run both your AIX workloads and your Linux workloads, same box, same server, and your training time actually is on the order of 4 times more models that you can process per hour on the Power 9 compared to x86. So I think that's huge. So I want to I'm going to camp on this time factor a little bit. So one of the things that you do a lot in training, in machine learning, deep learning, what you do is you spend a lot of time training your data. And so what does that mean? In the real world, where does your data live? Your data either lives in IoT sensors that are streaming in from someplace, or there are systems of records of customer data that's out there in a system of records somewhere. And so that data may be on disk, but at some point it gets brought into live memory, into your system memory, down through a CPU. And if you can do some machine learning there, cool. But as you know, most of the benefit you're going to get is through acceleration on a GPU. So somehow you have to take that real world data and you have to convert it. You have to bring it down in some way into the GPU. And so when you bring that data down into the GPU, if you're using a traditional x86 system, you're really pouring, say, up to 2 terabytes of a system addressable memory through a twizzle straw called the PCIe bus, the PCI Express bus. And that's a severe constraint. Somehow you have to feed the beast. You have to feed the GPU, and you got a twizzle straw to do it. Conversely, with the Power 9, with NVLink, our pipe is about 5 times fatter. And so this allows you really, and I'll show in some of the later slides, that you can address that full system memory of 2 terabytes rapidly. And so this is kind of a depiction of that. This is just kind of showing the Power 9 NVIDIA in Power 9 CPU with NVIDIA V100s. In this case, there's 2 CPUs in this box, and there are 4 GPUs. And so that pipe is going to be about 5 times faster than a traditional x86 with PCIe Gen 3. So if you're wondering, yeah, AMD does have some boxes out there that do PCIe Gen 4. So we have, I forget what the advantage is, maybe it's 4x instead of 5, but it's still huge. And so I want to talk about this, let's, instead of talking gigabytes per second, because most of us don't live in gigabytes per second, let's transform this discussion to miles per hour, okay? This is a typical GPU connectivity system memory. They call this an x86 box. And so what you're going to have is you can access through your CPU to your main big data warehouse out there, 2 terabytes. Well, they don't provide 2 terabytes, but a large system memory. You could actually truck that data back and forth at 77 miles an hour. Think of it that way. Now, the PCI Express bus allows 32 miles per hour of transit, but guess what? You have to share that 32 miles an hour between upload and download. So effectively, you've got 16 miles per hour that you can bring that system memory where your real world lives down to a GPU. Even if you have two of them, you've got a single lane highway going 16 miles an hour. So the NVLink between those GPUs, boy, they can communicate fast, but guess what? You have to feed the beast. You have to bring the data in from the system memory down in real world, right? So you're limited to 16 miles per hour. Think about that on your drive home, right? You got everybody's getting off work at the same time. You're trying to drive a single lane 16 mile an hour highway. Now compare that to Power 9. On Power 9, we have the Autobahn connected to your system memory. We give you a bigger warehouse, 2 terabytes of addressable memory, with 170 miles an hour. 170 miles an hour, think of that, right, to get the data to your CPU. And then we have the NVLink bus, which is, again, let's be fair here, 150 gigabytes. Well, we have upload and download both. So let's call it 75 miles an hour for download to get that data into the GPU. Well, okay, where do you want to be, right? If you're trying to feed the beast and you got data scientists waiting on the results, do you want to feed it with an expensive, even if you're renting an expensive x86 box, limiting you to 60 miles an hour, or do you want to do it with 75 miles an hour? And that really is the key value proposition here is time to value, right? And this is just another graphical depiction kind of showing that, take a typical workload on a typical x86 system. What this red bar is highlighting is the GPU utilization. White is bad. White is idle. Blue is good. You want to keep that GPU busy. You paid a lot of money for those GPUs. So in a traditional architecture, just because of limitations of bus, this is the kind of picture you're going to get on any given workload, right? When you apply that same, just because our processor, but really it's our bus architecture difference, you can kick out that idle time, get rid of it, or a lot of it. And what you're doing is you're compressing that. You're getting much higher, almost full GPU utilization, which is what you need for accelerated workloads. As Rafael alluded to, that machine learning and deep learning are really computationally intensive deals, right? So that's pretty much the end of what I wanted to say now. I'll get back to you on a special offer that we have on some hardware software bundles. But Rafael, if you want to kick off, or actually this is actually one for me. I'm sorry about that. This is a use case that we did with a freight enabling carrier. I'm sorry, Rafael. This is where we used driverless AI to look at being able to optimize routes and optimize times. We used H2O Driverless to do that. It took our SME, our specialist, working with the client, just a fraction of the time to use H2O Driverless to really derive insights into this scheduling thing, and they really got an excellent result. The company was incredibly excited about it. H2O, we worked with another retailer. This was, I won't go into the name of the retailer, but they had a variety of tasks to do, personalized product recommendations, supply chain optimization, pricing optimization, and next best deal offer. And they used a combination of our tools with H2O kind of sitting on top, and they were able to derive those insights. And they've been incredibly pleased. They actually re-upped and ordered more because they see the value in the hardware platform and that H2O sitting on top. This is just kind of how H2O sits on top of the architecture that IBM provides. So this is kind of our software stack that sits underneath it or can sit underneath it. So I'm not going to belabor that too much, but H2O sits kind of on top of our key technologies in the software stack that allow you to cover with one single pane of glass the ability to control multiple instances even of H2O driverless running. So there's a lot of advantages there. This is integration of AI. What's a machine learning accelerator? I won't go into that a lot. It's just really to say that we do have some software stack that can cover in a single pane of glass, even doing multiple nodes with multiple H2O instances on it. So we have that. That's available to you. For sake of time, I'm going to keep going. But Rafael, if you want, I'll turn this over to you right now, and I'll pick it up again when we talk about the bundle.
Thanks, Bob. So now I want to talk a little bit more like how does driverless AI actually do this, right? So part of the thing is that there's a whole workflow that happens in building a model. You start with data processing, model tuning, feature engineering. And this is actually an iterative process where you kind of go back and forth between different algorithms, hyperparameter tuning, feature engineering, and then you need to iterate through this and do this multiple times until you can have sort of a leaderboard of various models, and then you can select, what model you want to kind of go into production with. This is sort of another depiction of that workflow. So as we look at that workflow, really driverless AI is focused on this side of the workflow. So driverless AI doesn't do the data integration, data prep. We do have some capability to kind of have a data quality check using the exploratory data analysis features, but we really automate this whole feature engineering, algorithm selection, hyperparameter tuning, data prep, and interpretation kind of capability. If we wanted to look at the algorithms underneath, here's a whole collection of algorithms that come out of the box. Now there's a collection of algorithms that can also be added, but these are algorithms that are both CPU and GPU sort of enabled. So like IBM, XGBoost, TensorFlow, H2O, right? And we also kind of H2O is not only a tool company with driverless AI, it's also a core algorithm company. So these ones in black are algorithms that we develop for particular customer scenarios and have added into the framework. So as we look at the workflow, we'll start with a workflow where you connect to the various data sources, whether it's data in a relational database, Hadoop, or an object store, right? And then bring that data in, identify a label, and then we can start the exploratory data analysis, which we automatically generate a series of graphs. And then we kind of go into this automatic model optimization phase, right, where we kind of iteratively kind of try different feature engineering algorithms and do model tuning. And at the other end, we can kind of then look at taking a model and looking at explanations, exploring those explanations, looking at auto documentation. And once you're sort of settled with, the model, we give you this automatic scoring pipeline that you can kind of take into production. One of the things that's new with driverless 1.7 is before this gray box in the middle, this optimization box was a closed ecosystem, right? And now with driverless 1.7, this is an open ecosystem. It's an extensible and open ecosystem, so you can extend it by bringing in additional algorithms, additional scores, additional feature engineer transformers. And it's open because there's a library that has been contributed over 100 different recipes that you can leverage out of the box that we've kind of been working with different customers on. And it's also accessible in the sense of if you have your own secret sauce, your custom score that you want to optimize to, or your customer feature engineering that you've seen good benefits to, you can sort of have your cake and eat it too by getting all the benefits of automatic machine learning, and at the same time being able to customize that with your additional insights and capability. So we're going to go through a process of building a model. So we'll have a data set. The data set is a credit card data set, and we're trying to build a model to try to predict who's going to have fraud. And then we'll go through this process of optimizing the model, automatically generating a new model. So with that, let me go to a live demo. So let me share my screen. So can I get a confirmation that folks are able to see my driverless AI screen? Okay, so I'm assuming you can see my screen. And so this is what the driverless AI environment looks like. Here's you can see the data set credit card. We're looking at about 24,000 rows and 25 different columns. Here's each dot here is an actual model that's being generated. So let me go through the process actually building this. Right. So we can see the various connectors. So we have over 14 different connectors. So you can go to a file system. That file system can be in the cloud as an object store or a Hadoop file system, or you can connect to a relational database. So here I've uploaded some credit card data. So we can do some initial exploration and says, okay, let's look at this. Let's look at this data. So here you can see the column names and some of the distribution, some additional statistics for each of them. We see there's some demographic information about the individual, their sex, education, marriage, and age. And then we see a collection of lag features, historical features. So what has been your payment history over the last 6 months, right? And what's been your bill amount over the last 6 months? And what's been your payment history over the last 6 months? And lastly, we want to, here's the pattern of the label that we want to identify. Have you or have you not made your payment, right? We can look at the raw data and see what the raw data looks like. Once we've done that, maybe we want to continue our exploration, right? And we'll do some visualizations. So these are automatic visualizations that are generated. By automatic, that does not mean that we always generate the same 10 graphs, right? Really, it's automatic in a sense. We explore your data, we look at the data. Depending on the patterns that we see on the data, we provide you recommendations where data scientists can quickly go and verify their assumptions and hypotheses of the data, keep growing the insights in the data, and do a data quality check. So sometimes this could be 4 graphs, sometimes this could be 13 graphs. So for example, let's look at outliers, right? So in this case, it's looking at bill amount 5. It says there might be a potential outlier in bill amount 5. You can see the distribution here, and in red you can see an outlier that can be identified, right? So you can kind of scroll and have a discussion with your business owner. Says, hey, is this within range? Or you can even have a discussion with your data engineer or data prep person and says, hey, how did you get to this value, right? And try to identify if you have a good quality sort of data set, because garbage in, garbage out in any model building sort of process. If there's multiple ones, you can kind of scroll through various of them. We can also give you a correlation graph. So because this is supervised learning and we want to make sure that there's some sort of association or correlation amongst the various variables. Again, this is kind of continue sort of growing your skill set. So you can kind of see here that in red, means that there's stronger correlation. So there's a strong correlation in bill amount. So there's and that kind of makes sense, right? So if you think about like, oh, I owe $3,000 last month, maybe the month before I owed $3,300. And there's just also a strong correlation around your payments, how much you're making sort of month to month in your payment side, right? You can select an individual value and look at how the different other features are related or not related, and how strongly or not strongly they're related. So in this case, we can see some light correlation because it's in blue with these variables and features sort of identified. Once we've kind of gone through these graphs and sort of verified our assumptions and worked with the line of business and the data engineer that we have a good quality data set, now we're actually ready to actually build a model. And so we can go in here, we can say predict to actually build a model, select a test data set, select a label, right, where the example is, and now we're actually ready to start building a model. And so we give you 3 big nodes of key configurations around accuracy, time, and durability, and they range from 1 to 10. Right, so accuracy is really focused on the set of algorithms. So in this case, we're looking at sort of light GBM and XGBoost as an algorithm and the level of ensembling, and also has a big influence in the types of feature engineering. Right, so if we reduce the accuracy, you'll see a change in the set of algorithms. And so here you saw GLM being introduced, and the level of ensembling also went away. So we kind of returned to where we started, and we kind of look at interpretability. There's like a yin-yang effect between accuracy and interpretability. So interpretability, you can think of it interpretability/complexity. So as we bring up interpretability, you'll see it removing particular types of feature engineering, and also it removed the ensembling, right? So time is not in minutes or hours. Time is really the amount of effort, so the amount of iterations you're going to kind of go through. So for this demo, I'm going to reduce it down to 2, and we provide a score, right? So this is a default score that you're working with. In this case, we're suggesting that you do AUC. And this is an environment that's enabled with the GPU, so I can launch an experiment. So as I launch an experiment, we go through this, do a whole bunch of different checking, whether it's, see if there's any data leakage, any shift in your data, to help different checks on the different shifts and patterns that we see in your data. And then it's going to start going through a model build process. And at this point, we're seeing that it's using some CPU and some memory, right? And the GPUs are just starting to fire. In this environment, this is an environment with a 1 GPU environment, and pretty soon here we'll see models being built. This whole process is happening automatically, kind of selecting different algorithms, doing the hyperparameter tuning, doing the feature engineering, and this feature engineering and this whole process is happening in an evolutionary manner, right? And down here in the bottom left, what you'll see is models being built. So each yellow dot that'll appear here is an actual individual model that gets built. So here we're starting the process of building the first model, right? And our first model has been built at this point. Oh wait, now we have 2 models being built. But the first model is LightGBM, and you can see here the variable importance, right? And now actually within seconds, right, we have now almost 6 more models being built, right? And we're seeing different algorithms, and we're seeing it evolve and improve in its score, right? So in each iteration, we can see different models evolving and improving in its scoring. And this has only been going now for 1 minute and 44 seconds. So with that, we can kind of look at the classic confusion matrix, see graphs like precision recall, lift, and gains. And this experiment will now run for a few more minutes. But let's go look at a pre-built experiment. So here we can see an experiment that was already run and completed. So as we look at this experiment, the winning model at the end was XGBoost. We can see that about 137 models were built for model feature and tuning, 69 models for feature evolution, 10 models additional for pipeline, so somewhere in the range of about 120-ish models. Actually considered 1,268 features, but only leveraged them 32 in building a model, mostly probably because of the limited time I gave it. At this point, you have all these additional options to look at a summary report, right? So we can automatically generate automatic documentation. So I can kind of show you what that looks like. Let's see what screen folks are looking at. So I can download an experiment summary, look at a report that was built in the past, right? Open that report, and this is part of the auto documentation generated by our tool. Right, so we generate, here's auto documentation generated by the tool. This is a report of over 30 pages. We can provide an experiment summary. We're also going to get you details of the feature engineering that was built. Right, so here's the different feature engineering techniques, and the feature importance. Right, and we can say more details about the model. So we give you all the details about how we built the experiments, all the data checks, and some more information about the machine learning explanations that were built. Next, we can look at some of the explanations. I'll look at an explanation dashboard. And so these are various techniques that we use to explain models, whether it's feature importance, Shapley, dependence, disparate impact analysis, K-line. And we give you an interactive dashboard. We can kind of look at the importance of the different models. So in this case, we can look at an experiment where we're looking at an individual 11510. And we can get reason code. So, why was my, credit card applications are rejected? So I can look at a reason code that, look, because you missed your last payment 6 months ago, and because your demographic, at this moment we can't really offer you a credit card. And we can give you a decision tree to how you got to that decision. And we can also give you looking at the feature importance for that, not just globally, but locally for that one individual. How did you get to that decision? So it's like we can see in this case, globally, page 2 is the second most important feature, but for this individual, page 2 was the most important feature in how we kind of derived this decision. So let me go back to the slides. I'm going to stop sharing. Can we go back to the slides? Okay, so at this point, we've gone through the demo and, kind of give you how we build these models automatically, right? And at the end, we can kind of get ready to the point where we can actually deploy these models. So next, I want to talk about a special offer that's available. So Bob, do you want to provide more details about the offer available with IBM?
Yeah, absolutely. So we've got an offer right now that's available through the end of the fourth quarter, so kind of going quick. But really what it amounts to is an AC922. That's 2 Power 9 CPUs, 2 GPUs, those are the Volta 100s, 256 gigabytes of RAM, a couple of almost 1 terabyte SSDs and Red Hat 7.6, plus the H2O that Rafael has just demoed for you. Plus, we've got an H2O onboarding process. This is all part of that bundle, and we've got a special pricing there that I don't have the numbers, but if you want to know, talk to Lance, talk to Eric, and then additionally, my team, the CSSE at ibm.us.com, we provide a free consultation with a data scientist like me or one of my colleagues, and up to, if you want to, a free half-day workshop to kind of get you started. So that's into my spiel.
Thanks, Bob. So with that, we have this, automatically scaling platform in a partnership with IBM to try to bring the capability of expert data scientists to junior data scientists and accelerate their productivity from a junior data scientist to a senior data scientist, and help them reduce the time, not just only by automating the process, but by speeding it up by leveraging the IBM Power systems, right? Leveraging both CPUs, Power CPUs and GPUs, right? And doing this all in a way that's simple, flexible, interpretable, and enterprise ready. So with that, thank you very much for coming and joining this session. We could probably open it up for questions at this point.
Okay, great. Thank you so much.
Thank you so much.
Yeah, if you can mute that would be perfect. Okay, thank you.
Okay, thank you.
Okay, perfect. So we do have one question that came in, which we can go ahead and use the last few minutes for. If anyone else has questions in the audience, please go ahead and use that Q&A, send in your questions. So the one question we do have right now is, can you connect to DB2 as a data source, and how? So I'll open that up to the team.
Yeah, so yes, you can connect to DB2 as a relational database. So we do have a JDBC connector. So you can use your JCC driver from DB2, go to our JDBC connector, configure it. Once you configure it, then it'll be available on the UI. And then you can, when you go run it, you can provide a SQL statement, which will identify the set of data to bring back into driverless, and then that data will be loaded into driverless AI.
Perfect. Thank you.
Thank you.
So why don't we spend the last few minutes going through your getting started slide here, and then we'll wrap up.
Well, thanks. So as we look at folks getting started, there's a whole collection of assets. So there is a 21-day trial that folks can leverage. We also have a free trial experience in the cloud, so we can give you 2 hours on the cloud for free via this test drive. And then we also have a whole collection of tutorials. So we have something in a range of 6 tutorials that walks you through the beginning steps of building your own model for the very first time, and walking through the process in a very prescriptive fashion, and also giving you some conceptual information. And so we have tutorials around the basics, how to interpret these different results, machine learning explanations, building time series models, and using some of the new extensibility and open recipe infrastructure. We all, like I mentioned, H2O World is coming around the corner, and there are all the replays for the older H2O Worlds are available. That's a great place to learn from the experts and from customers on how they've been using it so far. And hopefully it's a good opportunity for you to learn more. So hopefully you can make it to H2O World in New York. So those are the introductory and getting started topics. Any other questions so far?
Yes, we actually have two that just came in. So the question we've got first is, you might want to mute for a second. Perfect. Thank you. So the question is, can you drag and drop data from multiple sources and formats from, say, a DB2 system and S3?
So you can drag and drop different data sources, right? However, if you want to kind of bring those two data sources into one data source, that merging needs to happen outside of Driverless AI.
Perfect. And then the next question that we have is, does the compression or serialization format matter? AVRO versus Parquet, et cetera?
Yeah, so we can support multiple formats in the Hadoop environment. I'm pretty sure we support Parquet. I'm not sure with, where we're at with Avro, but we have a series of file formats that we support from the file system and from the Hadoop environment. So you can check out our documentation, docs at H2O.ai, then go to Driverless AI, and we can list all the different file formats that are supported.
Great, thank you. And thanks to everyone for joining today. That's all the questions we have. So we'll go ahead and wrap up for today. You will receive an email with the playback link as well as the presentation materials. So again, thank you so much for joining and have a great day.